So we've been spending a bit of time looking at Pythagoras' theorem, looking at the finding the longer side, so the hypotenuse, and the shorter side. Pythagoras' theorem can also be applied to test whether a particular triangle is actually right-angled. And this is what this video is going to demonstrate, how to approach a question or an application where you need to determine if the triangle you are looking at is actually a right-angled triangle. So we've got two triangles here. Now, I'm just not going to use my eyes and go, yeah, that looks like a right-angled triangle. We're going to run with that. We're going to look at this mathematically and be able to apply Pythagoras' theorem. So the first thing I need to do when approaching this, let's write out Pythagoras' theorem. So a squared plus b squared equals c squared. Okay. Now in this case, okay, 45 is going to be c, and it doesn't really matter which ones you associate with a and b, provided they are the shorter sides. Okay, so I simply write it up my equation. I substitute in the values from my particular triangle. Now, what I'm going to do now is I'm going to test whether 45 squared equals 36 squared plus 27 squared. So the first thing I need to do, I need to know what is 45 squared. So that is 2025. Now I need to know what 36 squared plus 27 squared actually is. Doing that, 2025. Now let's read this out loud because it makes a lot more sense when we do this. 2025 equals 2025. There is the same number on each side, which means that this is true, which means this is true, and what I'm going to write now, okay, so the three dots, therefore this triangle is right-angled. So it is a right-angled triangle. Okay, now let's use that exact same process for this triangle over here. I don't know whether it is a right angle or not. Again, let's write out Pythagoras' theorem. Okay, so with c squared, okay, that's going to be 15, okay, equals 14 squared plus 6 squared. Now let's find out what 15 squared is. Okay, 225. 14 squared plus 6 squared, 232. So does 225 equal 232? No. Okay, they're not the same number on each side of this equation. Therefore, this is not true. So based on these mathematical findings, think of it like science. Okay, we're getting our evidence and now we're drawing a conclusion. So therefore, this triangle is not right-angled. Why? Because it does not adhere to Pythagoras' theorem. Okay, it doesn't fit in. Okay, because when we substitute the values in, we get two different numbers.